I've explained you something about the differences between ant and maven, the advantages of the maven. Okay, then we set up the maven. Okay, and also I've gone through the maven structure, form structure. The default XML is a POM.xml, and I've explained the maven life cycles, three life cycles: default, clean, and site. Okay, so what are the phases in the default? Validate, compile, and all these things. And we have taken one sample project event, a sample high-level program. Okay, and we built and we installed. I mean, we have gone through all the life cycle except the last install and deploy. Remaining everything we have seen in the last session. Okay, till here, till the package. So we need to see install and deploy. So before that, and this is what the content which I typed on that day, which we will be discussing today. Okay, so Maven has its own code repo structure and all this is done. So I need to go through with the web application build. So last session we created one standalone app, which is the artifact of that app is going to be a normal jar file. Okay, so I can show you that code base with you. Just look at this Maven practice. Yeah, app. It will be having a source code and a POM.xml, and this is what your POM.xml. It typically contains your application name and its version. These are all called the coordinates. Okay, coordinates will be four. One is your group ID, artifact ID, your packaging type, and your version. Okay, then you will be having the dependencies. So here it will be having the compile dependencies and runtime dependencies. So right now this is depending on the JUnit actually. So this is what the sample application which you see, and we ran the entire stuff the performing the clean, compiling the test classes, executing the test, everything. So this was the same app, guys. I'm there in the same location, app location. So let's try to perform MEN clean. What do you mean by MEN clean? Clean is a life cycle, not a phase, guys. This will delete the target directory. Okay. If you have any output directory here, parallel to SRC, you can find one more folder called target that will be deleted automatically. Right now there is no target directory, so it is not deleted. Let's try to compile. Okay, so this will compile the source code exactly. Okay, so if it requires any binaries, right, it will download from the internet. Okay, this was the Apache Maven repository, so it is downloading all of them to compile your code, and same thing you will see it in your machine event. And this downloading will take only at the first time, so second time onwards it will not download anything, so it goes fine without any issues, because these are all the different libraries Maven software requires actually to compile any code and all. Just wait for some time. It is downloading right now because I changed my laptop, guys. Last week laptop is the other one and this is the different one. Okay, so all those download things were there in the old laptop, so I'm just running first time, so that's the reason it is downloading everything. Otherwise it would not gone through this much of time. So let it download. Meanwhile I'll discuss something else. Okay, my dog. Yeah, we need to prepare one web application build. Just as of now, you've seen a standalone application. Let's see one web application as well. Okay, so we can create template web application using the Archetype template. Okay, only thing is you need to pass one more parameter, it is a web application. And I've gone through the typical source code structure of any Maven application. This is something like this. Okay, a project will be there, and you'll be having a source. Inside that main nothing but your source code, test nothing but your test code. Okay, and your POM.xml. This is what is standalone application. So similarly, how a web application code structure will be there. Okay, code structure. So it is almost same like standalone, but one extra directory will be there. So inside the SRC main, okay, so you will be having something called web apps or web content, something will be there, web apps. Okay, and remaining as usual test. Okay, test, and then POM.xml. Okay, so one extra folder will be there, web apps. Just like if you've seen an ant one application I explained you, right, web application, where you see the static content and dynamic content. This web apps contains the entire static content. Okay, and dynamic content is going to be your Java code, guys. Okay, so let's try to create this structure with the help of the Archetype. So last week even the main app also we created with the help of Archetype command, and this is what the Archetype command. Okay, and using this Archetype template command, we have created the sample app for the Java application. Okay, who joined the call?
Hi Chiranjeev, Krishna.
Hi Krishna, thanks for joining. Yeah, we just started. I'm just not even 10 minutes, 5 minutes it is. I was just recapping the last session. Okay.
Okay.
Yeah. So, okay. So using this command, we generated the last week the sample application, which is standalone. It will generate only a jar file, nothing else. Okay. Now we are trying to work on a web application where how to generate a web application template. Okay. So for that, similar kind of archetype only. Only thing is one extra parameter you will be passing. That is a type of web app type. So I have that web application type archetype. Yeah, this is for a standalone. Okay, jar file. This is for a war file. So copy this one and just come over. Okay, let me increase the font. Word wrap. Okay, so look at this, generate, and this is what my web application com web app is group ID, sample web application, and this is going to be my artifact ID and artifact ID type, which is going to be Maven archetype web app. This is what extra parameter you will be giving it. If you don't give this parameter by default, right, it's going to create a standalone application on it. Okay, if you provide this any external input like this web app and all, it will create that type of application. So let's take this example and go to the command prompt. Okay, it is failing. Let's see why it was failing the earlier one. Project app execution default. One second, guys. I think there's some issue with the new Maven, which is set up right now. Let's try to download little older Maven. Maven 3.5. Which is 333, which I downloaded. Go to the archives, little older one. Do you see anywhere archives? Yeah, previous archives. Okay, 30305330. Let's take 311 and binary. Try to get the zip, zip. Yeah. I'm getting so much of noise from you. I'm just trying to fix the old application build issue, guys. Let's work on web app. Give me some time. So I just downloaded a little older one. Kiran,
Yeah, Chiranjeev.
can you please keep yourself in mute, please?
Yeah, it's already.
You are not in mute, man. Let me go to Maven practice. Where is it? So I was having 331. So I'm just checking this one. Go to the environment variables. Set this to 311 and go to the path variable, edit, and try to edit the bin path. So when you do the changes, this will not work here. You have to open a new command prompt. Open a new prompt. Go to the drive. GN practice. Maven. App. Maven clean. Compile. Okay, this time the compilation is good with the older version. See, guys, even the newer version should work, but there are some dependencies like the newer version should require Java 8 and all, but I have a Java 7. Okay, so we have to spend some time and Google the issues and fix it. So let's not waste time on that. Now, so clean is working, compile is working. Similarly, you can say install also. Okay. So install nothing but it will do the compilation of test cases and test package, then install. So this will install it into your local repository, which is .m2 drive. I'll explain that install phase later, but right now understand when I call install, this will execute all these steps. I mean these phases prior.
Where did this place the compiled files to?
Yeah, I'm coming over there. It will create a directory called target. Okay, you look at this. Can you see target? So this is
okay.
Yeah. Inside this, it will keep your compile classes. Can you see my company app.class, something like this. Okay. So right now, the compile. This is what the older file compilation. Okay. Right now, I triggered a phase called install. That's nothing but it will compile not only the source code, it will compile your test class also. Can you see new file, new directory test classes? So it is compiled test classes. Also, it will create a jar file here. You just watch over there. In the background, it is doing the things. It will create a jar there. Can you see jar here? app-1.0 jar. So it is doing everything in the backend. Now once this jar is done, you're packaging it. So it is doing step by step. First compilation we already did it. Now when I call install, right, it will do the again compilation and compilation of test cases and running the unit test, then packaging. Packaging nothing but generating the jar file. Right? Now it is downloading few more libraries. Guys, this is one time. It won't take much time actually. Next time onwards, it is downloading everything first time. Okay. So wait for a while. So then what do you mean by install is, install will copy your jar file from here to your local repository. That will be storing in the your username of your machine. Mine is a KH117. It will create a directory called .m2. Inside this, there will be a folder called repository. This is called a local repository. Here you can find my company something. What is it? Is it a my company? My company. It's not there still. So once the entire job is finished, you can find my company here and the jar file. So it will push the jar file into this local repository. Then you might be thinking, what is the purpose of install? What you will gain by keeping the jar in the .m2 folder? The thing is, when you have two applications, assume this entire is a application, okay, and you have one more application called B, okay, and B can compile only if you have a.jar file, okay. So what you will do in the B pom.xml, you will mention A as a dependency, okay. So something like this, you prepare one more dependency, like A's artifact details you will give it. So from where can it will download? It will not download from the internet, because that is a.jar is your jar. It is not given by Maven. So where can you find that? So your machine can find that in the local repository automatically. Your machine nothing but your Maven. So it's successfully done. Nothing but, can you see my company here in the .m2 and go into the app? Can you see the 1.0 and jar version in your local repository? So that's what install does, guys. So install will copy your artifact to your local repository, which is .m2 folder in your user location. Okay. So that's what we did for the standalone application.
Okay.
Yeah.
Chiranjeev, I have a small doubt here. Why do you actually you create the build files on the server, but why do you do it on your local machine?
Okay, let me come to the first part of the Maven, because we treat yourself like a developer. You're not a kind of build engineer or deployment engineer. Okay?
Okay.
If you are a developer, you have to compile your code first, right? Before giving it to the, before committing into your source code management system or giving
Yes,
it to the
yes,
builder.
yes, I understand.
So yeah,
Yes.
so you have to compile the code. So you have to, when you're compiling the code, you have two applications. Second application depends on the first application. So how do you manage that dependency? So for that, these kind of scenarios, Maven maintains entire libraries in a local repository in everybody's machine. Who's are running the Maven, it will definitely will create the .mp folder. Okay, so that's how, like, this local repository concept is introduced in the Maven.
Okay, so this is called local build, which they validate before adding it to source control.
Yes, you are absolutely correct. Okay, they are verifying it everything. Okay, yeah. Now, yeah, let's come to our main topic, which is the web application, creation of a web application. So I just copied this command. Okay, come back, and we are done with the standalone. That's it. Nothing is there in the standalone. So developer will be keep on adding the Java files, and the structure is same. Okay, and the build process absolutely same. There is no change. If it is and, you will be like keep on changing your build.xml. But here it is not required. The developer will take care of adding the dependencies. Your job is to just trigger the build. That's it. Come out from this project and try to run this command. This is going to create a sample web application structure. So it's generating a project structure, guys. Sample web app is a structure, a source code, pom.xml. So everything is created. Can you see successful it is? So now come back and check it out, the source code, the structure. You will be seeing one different folder. Inside the main, can you see web app and resources? This is what something new you see it. Okay. So this is what the structure of a typical web application is. Okay. So here right now in your web application, I don't think you have any source code, guys. Okay. Even you compile something with this web application, nothing it will run. So you go into the sample web app and cls men clean compile. There is nothing to compile actually. There is no source code available there. So no source code is available. So you can see no source to compile. So it is just generating the template for you. Now what a typical developer will do it, he will keep adding the source code here. Okay, he will write Java directory. Okay, Java directory, and inside that he will write all his structure project structure com.mycompany.hello world blah blah blah. He'll be keep on adding the code and he'll prepare it. But the difference which you see it from the standalone application and this, right? So if you look at the POM of this one, sample web app POM. So you will be seeing packaging type as a var. Did you observe this? So for a standalone, this was a jar. Okay, and for this it is a var. So when I say var, nothing but it requires even the web content folder also. Web content nothing but inside the source you can find one more folder called web app. Okay, so this web app is the folder where you have a web.inf, the libraries and web.xml. Okay, these are the mandatory fields if you remember the AND session, right? So where you can get, where you can see in the sample web application web.inf directory index, the sample files JSPs, HTMLs, XMLs and all, and on web.xml. Okay, and few resource files, so few libraries, everything will be there inside this web application. So whenever your Maven is bundling it or making a var, it will make this web app as a part of your var application. Yeah, Ranjit. Ranjit, I can hear you. Okay, so now I need some source code to compile this code and all, but this template is not helpful for me. Let me take one any of the sample web application which is already prepared. I might be having a web application and practice. Let's take our ant web app build itself. Yeah, Kiran?
Yeah.
You're unmuted again.
Can you hear me?
I can hear you. Tell me, any questions?
Yeah. Actually, we have created SRC folder.
Okay.
Why should we create that one actually?
That's
Every time we
no,
create the
no, we don't.
we have to create manually.
Listen. We don't create the code structure. This is done by a developer. Again, I'm saying treat yourself like a developer when you're working with a Maven. Okay. See, when it comes to a build engineer or a deployment engineer or DevOps engineer, there's nothing to do with the Maven actually. We are executors. I'm just giving the behind before you execute the things, what exactly typical developer will do it, how he will create the project structures and all. That's what I'm trying to explain now. Okay, you don't create this source code and all always.
Okay.
Okay, yeah. I'm just saying, like, how a typical developer, when he's starting up a new project, how he prepares the code structure in the Maven. That's what I'm trying to explain. That's it. Am I having any web application? I'm just looking for sample web application, guys, to show you the build. I think in my old laptop I have those things. Let me download from the Google some application. Sample Maven web application project. He's also using the same thing, okay, but we don't get the source code by doing that. I'm looking for some sort of a source code, guys, nothing else. Okay, am I having anywhere? If these guys can provide the downloadable source code, that would be really great, because I have all this source code and all in my old laptop. Can I see download anywhere? Yeah, download. Here it is. Okay, just download this. Take this counter web app, some web application he is giving it, copy to your folder. What is this? No. Okay. An app I have it, so I have a Pomodoro XML. You can remove this, guys. This class bar dot project will created by Eclipse, because developer will use the Eclipse, right? So this dot folders will created by automatically Eclipse, because Eclipse has its own properties, IDE. Whenever the project is loading into the Eclipse, it will read this class path and dot project files to make visible into the Eclipse actually. Okay, for you it is not required, even the settings also. Okay, so I just need only these things. Now try to go into the directory and well build it. Counter web app, MVN, compile. Let's try to compile first. And you look at his Pomodoro XML meanwhile, how it is looking like. See, his package was war file again, okay, and he's having the this coordinates. This is a group ID, and this what is the artifact, and the package type, and this what is the version. Okay, you can give any version, guys. We are giving as of now 1.0 is giving snapshot. I'll explain about snapshot, normal version, everything later. But right now, just take it as it is, whatever is there. And look at his project. He is having multiple dependencies and all. Look at this. 1, 2, 3,
Okay,
4.
Chiranya, I found out. You know, in the build screen,
Yeah.
can you go to the command prompt where it is building?
Yeah, this is what the build screen.
Yeah, it is saying downloading http repo.maven.apache.org.
Yes,
Is it
yeah.
actually connecting to the website?
Yes, of course. I have a net connectivity to you should have a net connectivity when you're running Maven. Okay. Otherwise,
Okay. Even when you're running the builds on the server.
okay, even on the server you need the net connectivity. Okay. Now
Okay,
you
but
yeah, I'm coming over there. I'm coming to your question. Okay. See, most of the secured environment, they don't provide the net connectivity to your environment. Okay. In those scenarios, what you're supposed to do it. Okay. One workaround is in your machine, you perform entire build everything. Okay. Then you blindly copy paste your .m2 folder from your machine to the server home directory. That's it. It will never download, because the downloading will happen only once, not every time. Okay, this is my new laptop. That's everything is downloading now. Okay, in my older laptop you have not seen all this downloading, because I ran many times with the Maven, because it's already there in my .m2, so it won't download. Now if you try to run the same compile, right, check it out. I'm just running it. It will not download again. It just compile. How frequent? How soon it is? See, 0.7 seconds. It is completed now.
Oh, okay.
You understand, right? So one time download. Okay. So that is one way, and there is one more way is there. Instead of
And does that need to be, say, for example, if you get new version of source files or .empty folders, do the companies usually do it frequently, like every month or every?
Listen. I didn't completed my statement. There are
Okay.
two ways I told you. One workaround is you copy your .m2 to server. That is a very basic one. Anybody can do that. Okay, but that is not an ideal solution to do it for every change or every new version of it, because every time in every 2 days developer will do some new changes, a new jar file required. So you cannot do every time this copying into server, right? And you don't know which file has been modified. So instead of that, there is a concept called remote repository. Okay, so using the remote repository, you don't need to connect to the server. Instead, the developer can place the things into the remote repository. That remote repository is something like a public repository which access in the internet, right? So all of them, you keep it into your local intranet repository. That is called a remote repository. So that intranet repository is within your LAN, within your company network, and your server can access it. So that you know to copy the .m2 always, and your Maven will listen to that instead of the public repository, which is of the Maven. You understand, right?
Okay. Do we need to change the path or anything else for the Maven?
Those are all the things we have to do it. Our next topic is the same thing. I need to explain you. Okay. See, just wait for some time. You'll understand. Can you see remote repositories concept? So I'll explain that.
Yes.
Yeah.
Sure.
So we'll talk about that. Then you'll get an idea how it works in the servers and all, right?
Oh, okay. No. I was just confused about the build screen saying that it's downloading from that, and it's not allowed.
I understand it's not allowed in the server, but it will download from your local, your remote repositories actually in the server. So that kind of configuration you have to make it, right? So now this time the build has been successfully done, and if you look at the target directory, can you see target and you see the class files and all? Okay, but actually I don't want the class files. I need my package. So this is a web application. Okay, I need a package of war files. So to get a package, you can run the mvn package command. It's okay. This will prepare a package for you. As I'm running the package, first time we download a few libraries actually. Okay, second time onwards it will not download anything. When I run package, it will also go through the test cases, execution of test cases. Okay, fine. I don't think any test cases are there, so it's finished it. So now come back. Can you see counter web app.var here? So it successfully created the web application now. Now if you look at this web application and try to open it in 7-zip or Win or any software, you can find the dynamic content and static content. You go into the web enough. Can you see these are all the static content, and classes com is your mycoms, the code. This is what the code actually. Okay, the basic compiled .class files, and the rest of stuff is the entire static content. You have libraries and all. So these are all your libraries. Okay, and these are XMLs, and web.xml is important file for your web application, right? So everything it will bundle it, okay, as part of your packaging. This is what a sample application. The difference between a standalone, this is it will be generating a war file, it will be having a web content. You look at the structure also, you'll be having a Java, apart from that, web app and resources folder. Okay, resources contains only some few documents, configuration files and all this. Log back is one configuration file. Okay, so this is what the structure of a typical web application. Okay, now the process is same again even for web application. You can compile, package, and you install. So install nothing but the same var will be copied into your .m2 folder. Okay, right now we didn't install, we just packaged. If you want, you can install also. So this is what a typical web application look like. Whichever the application you see, it's same process, guys. Okay, only thing is the difference which you see is that the outcome will be a var file. Okay, now other life cycles are nothing but we have seen the default life cycle. Okay, and we have seen the clean life cycle. Clean nothing but will delete the output directory. You are seeing the target, right? Okay, when I say mvn clean, okay, remember clean is not a phase, it's a life cycle. Okay, it will delete the output directory. That's it. Output directory is a target directory, right? So that's what the clean life cycle. But you cannot call mvn default life cycle. See, default lifecycle never called with a default name. Okay, it is always called with a subset of default, which are called the phases, like compile, package, and all. So this is what we have seen in the last session. Same thing I'm just trying to explain. So these two are done, right? There is one more lifecycle is there, which is site. Okay, so if you look at the previous last session class, can you see default, clean, site? So you know the default and clean. Now let me explain you the site. What do you mean by site is, site will generate just HTML documentation for your project, nothing else it will do it. Okay, it's a kind of a user-friendly documentation where somebody wants to walk you through with your code and your structure and all. Okay, you try to generate the site, it will generate a report of your source code, and that report can be seen by any developer or TL to look into the what exactly your source code. Okay, the Maven has a default feature to generate a report from your existing source code. So you have to run a site command. This will take care of generating your report. Site is a life cycle here. Now you look at output directory, guys. Does it create output directory? No, not it. I think it will fail, guys. And the reason it is, I don't have a target. This should have some sort of source code. No. It requires only source code. Dot class files, I don't think it is required. Let's see. Because we never run site individually, we run site with compile package and all. So many libraries are there. So first time, even in your scenario also, you have to wait for some time. So once it is done, that is really good, because next time onwards your work will be so fast. Seems to be so many libraries out there to generate the site. Okay, let it go on. Meanwhile, we'll talk about some other topic. Okay, so that's about the site lifecycle. So generate the documentation. Now let's talk about the repositories. Okay, so what do you mean by repository in Maven? Okay, see, in the last session I told you something about segregation of source code with the libraries. Okay, in Android the project structure is something like your source code, your dependent libraries, everything together you commit into your version controlling system. That's a really kind of bad task, or you can say bad environment. The reason it is, you take 100 MB of source code, your source code won't be 100 MB actually. Your source code might be 10 MB, remaining 90 MB is libraries. Okay, and if you see if you see a bigger project and you same repository have 100 applications, something like that. Okay, if 100 applications are using 5 jars, with the same jars they're using it, right? They will commit same 5 jars, okay, 100 times. So it's a really bad practice, and we don't have a proper mechanism to manage those libraries in the end. So that's where Maven came into the picture, and Maven completely segregated your source code from the library. So where you can maintain your library separately, okay, and you maintain your source code separately. If you look at any of the source code here, right, your sample app, counter web app, anything, all of them are what? Just a source code. They don't have any library. All libraries are maintained in the .m2 folder, which is a local repository, and your Maven is quite smart enough to download them, keep it into some other location, and make use of the libraries whenever it is required. That part is taken care by your Maven. Okay, now when it comes to repositories, right, so whatever the libraries your Maven downloading it and keeping it in your machines, okay, so that repository we call it as the local repository. So local repository. So what do you mean by this is, so downloads the dependent libraries and keeps them in home of the machine. Okay, inside that it will create a directory called .m2. So inside this it will create a directory called repository, right? So inside this it will keep all the libraries, guys. Okay, this is what the location. If you are a Windows user, the home will be C:users. If you are a Linux user, it will be /home/ something, okay, your username. So home, this is the location, and this directory we call as a local repository, and this contains all your libraries. Okay, so this updating or downloading will happen in the first phase of your default lifecycle. Okay, validate phase will download will download all required libraries into .m2. This I told in the last session. The phases you are seeing, right? Default lifecycle phases. The validate is the first phase. Before proceeding with the compile and all, first it needs to download all the dependent libraries. Then only the compilation will be successful. So that's the reason validate will run first. Okay. So whenever the validate is running it, right? So it will keep all those libraries into the .m2 folder, and this you call it the local report, right? Now, once, okay, now this has happened fine. So second time what happened, you are running the same job, nothing but same compile, okay? So when you run the second time same compile, it will not download the libraries from the internet, again, internet nothing but the Apache repository. Instead, it will look into your .m2 folder, okay? The thing is, in a project, take a project, okay? This project has 8 library dependencies, okay? And you are running first time, guys, okay? So this is what your project, when you're running the first time run, so what will happen? The validate phase, okay, first hits local repository, nothing but .m2. First it hits the local repository. I would better use the pen, then you understand much better. Guys, treat this is your machine, okay? And you have your project here, okay? And this is what your local repository. Within your machine you have a repository which is, I'm calling this as a .m2, okay? A stored location, some storage, okay? Now whenever you trigger your project, okay, and you have something like, you know, Apache repository in the internet, Apache repository, okay, in the internet, and this repository we call it as a central repository, central or public repository, okay, public repository, right? So whenever you install a Maven, set up a Maven and run the project, right, pom.xml, first it will check the dependencies in the .m2 folder, guys, okay? First it will check it in the .m2. So this is nothing but first, okay? First it checks in the .m2. If it finds in the .m2, it compiles fine, it doesn't require any internet, nothing. If the libraries are there in the .m2 folder, right, it won't require any internet at all, it compiles fine, packets, everything it does, okay, everything it completes. But when you're putting up in a fresh laptop or a new server where your .m2 is completely empty, so first it hits, if it didn't find right, it will not fail, instead it will hit your public repository, okay? And this is what the second priority, okay, second hit, okay? This is what your first hit, guys, okay? Local repository, first hit, right? Now whenever it is hitting the central repository, right, it will not download into the project space, guys. What do you mean by project space is your source code structure. It will not keep it into your source code actually. Instead, when it is downloading the things, see, definitely it will find it in the public repository, okay? Because Apache maintains pretty much all the libraries, okay? Now it will download the things into, whenever it is downloading, it will download into .m2 only, okay? So whenever it hits the central repository, it will download all the libraries into your .m2 repository, okay? So once it is there in the .m2, right, okay, first time, once it is downloaded, then again your project will look into .m2 and compile. Second time when you hit it, right, look at the priority first. It will hit the .m2. It finds there, so you don't require internet. So only for first time you need the network where it will download from the Apache repository, keeps in your .m2. Second time onwards you don't require, because it is downloading everything and keeping into your .m2. But sometimes you may need internet where the developer put one new dependency which is not there earlier, okay? Then at that point of time, of course it is not there in the .m2. It connects to the central repository and downloads it and keeps it into your .m2. So this is called the repository management in the Maven, where you have the public repository and the local repository, okay? These are the two types of repositories which you have it. So the diagram would be much better instead of this explanation here, okay? So that is called the local, is called the .m2, and you have one more repository called the central, okay, which is a public repo maintained by Apache to download the libraries, okay, libraries, and keep them in .m2 only, because next time you don't need to connect to the public server again. Okay, because connecting to public server is expensive operation for your machine, right? So did you understand the repositories concept, guys? Local and public repository, all of you?
Then
Yeah.
I have a question here.
Yes.
Yeah, actually you told that all the dependency downloading is first time from the Apache, like central repository, right?
Yes. Yes, you're right.
Yeah, for example, for day by day, every dependency will be added by the developer.
Yes.
So at that time, compulsory the net connection should be there on that mission.
Of course, it should be there.
And one more, the dependency will be taken by the always developers only.
Yes.
In Maven project.
Yes, developers itself. We don't do anything over there, because they'll come.
Because of we will write the add system, right?
See, the thing is, if you are taking care of the dependency, right, you should know what code you are writing it, right? Are you writing the code? No, right? Developer is writing the code, so he will be knowing what exactly the library depends. So he will add into the dependencies. You are not involved over there. Okay. Fine. So now I talked about two types of repositories. Okay. Now let's come to the third type of repository. Okay. First one, this, and this is what the second one, and this is what the third one. Okay. Now I'll give you a scenario for you guys. Okay. The scenario is, look at this diagram. There is one more developer is there. He's a B developer. Assume he is a developer A, and he is a B developer. He is a B developer. Okay, and of course he set up the Maven, and he has the local repository, which is a .m2. Okay, folder. Next, he has a project. Here's a project. Okay, now he has a dependencies again, the same concept, guys, like how the other developer is saying, but a small glitch here. Thing is, in his formatted XML, he put one dependency as a dependency, developer A. So this jar, so the jar which this part generates is called a.jar, guys. Okay, a_a-1.o.jar. Okay, now this guy is should generate a b-1.jar. b-1.o.jar. Okay, now to generate this b-1.o.jar, he needs a.jar should be there in his .m2 folder. Okay, then only his code will compile properly, otherwise the code will not compile. This is called internal application module dependency. That's nothing but in your project you have multiple modules, multiple people are working. Now instead of depending on the central repository, nothing but central, typically what you depend, your Struts, Hibernate, okay, Spring Framework and Log4j, Gen, these are all the publicly available. You can get it from the Apache central repository. But this a.jar is developed by your own company, one of the team, other team, and you want that your friend developed it, so that you cannot keep it into central repository actually. Okay, so central repository contains the main frameworks and all. They don't keep your code base. Even you are not supposed to keep your proprietary code base libraries into your central repository. Okay, they don't allow it, and you are not supposed to do that. Now, how I'm going to share my a-1.o jar with my other friend bdev, okay, to compile his code, because to compile his code he must and should need a-1.o jar. Okay, now what is supposed to do it? So with the typical workflow of Maven, right? Okay, looking into the central repository, it didn't find first it looks into the .m2. Okay, the first hit, guys, this is what the first hit. Okay, it didn't find it here. Now second hit, okay, second hit is going to be central repository. It didn't find here. So if it didn't find in the .m2, if it didn't find in the central repository, what will happen? The build will fail and it comes out. Okay, now you are thinking, okay, this doesn't have the a-1.o jar, that's when it is failing. So now what you're supposed to do it, you ask your friend, okay, and ask him to, like, could you please share your a-1.o jar, so that what you will do it, you will copy this a jar into your .m2, guys. That's it, nothing else. Okay, you copy it into this here a-1.o jar into your .m2 folder, like a.jar, you copy there, and then you build it. It is successful. Okay, so this is one way to make your B as successful. But the thing is, Tomorrow you have 10 jars dependencies. Okay, one jar from A, other jar from C, other jar from X, other jar from somebody else. Now, day after tomorrow, this guy changed the source code and he got a new jar, A2 dot whole jar. Okay, now you need to A2 dot whole jar. So getting the multiple jars from multiple people, multiple version is really a painful task, and you cannot manage it, and it will lead to do some sort of like bugs. Okay, and your compilation may not be successful, and you may not be able to deliver the right code. Okay, that's a big problem when you have the internal dependency modules. Okay, so internal dependency between your own modules. So that's where, okay, we need to come up with a different approach which should sort out this kind of problem. Okay, the approach is going to be, we will host our own remote repository, which is going to be this is what I'm going to host a new repository. Okay, this I'm calling it as a remote repo. Okay, so we need to host a new repository called within your company, guys. These are all within your company. Okay, so this part is within your company. Okay, that is external live. Apache repo is external in the internet. Okay, within your company you have to host your own local repository. Okay, now in this local repository all the developers will share their artifacts here, and if somebody else is there, they'll share the artifact, nothing but they'll store the artifacts here. They'll not give manually to the other developers, you take this and you compile, you take this, you compile. So they don't do that. Instead of that, they put all their their artifact nothing but a dot jar is there, he will keep it here. Another C dot jar, he will keep it here. Now as a B dot jar, instead of I'm asking the A guy or C guy or D guy, right, I will look into this shared repository. My Maven will look into the shared repository. Okay, so this is called a third repository, and your Maven by default will hit the third repository as a third priority. So this is going to be your third hit. Okay, so the first hit is, if a.jar is there in my dependency, my Maven pom.xml will first look into .m2. So okay, so it is not there, it failed. Second hit, it looks into Internet Apache repository. It is, of course, it is not there. That's your own company jar. Okay, it will fail. And third hit is going to be a remote repository. It is there. Now from here, what it will do, it will download that into your, again, just like how it is downloaded from central repository, it will download to your .m2. Okay, it will not make you directly. It will download into your .m2, okay, and keeps it in your .m2. In case if you want to do second time build, it will not download from again remote repository, guys. Even it is within your company also, it will not download again, because unnecessary it is expensive operation from within the network. So that's the reason it will keep it into your .m2, and it will look into the .m2 first. Anyway, because the sequence is .m2 central repository remote, right? So in the .m2 itself you got the jar, and it compiles fine. It will not go to the second and third hit even. So this is how the remote repository works, guys. Okay, and this is called the third type of repository, and the repository name is called the remote repo. Okay, so within organization, okay, within organization we will set up set up our own repository. Okay, so that's called the remote repository. This is going to be like a third hit in Maven repository sequence. Okay, forget about my words and all, but I want you to understand the concept. Okay, the documentation, leave it. Some points like remember what exactly it is. Okay? So this is what the entire your Maven lifecycle architecture, guys, how it deal with the different types of repositories. Okay, please guys, this is really important. If you understand this entire workflow, right, you think about everything about Maven, because that's what it does in the backend. Okay, actually, okay, nothing else. Now, yeah, yes.
Does .m2 is the industry standard name, or is it called different in different?
It's a Maven given name. It's not about industry. Maven. It's Maven name actually. Maven is creating the .m2 automatically. You don't have to worry about it. It will create automatically .m2.
Okay, and the remote repository can be called with any name.
Any name. I mean, it's not with any name. That's something like, the Maven guys is provided, okay? Apache something reported. They will take care of it. You don't have to worry about it. You just mention the dependency and the Maven will call the required one.
Once the b-1.jar is copied all the files from remote repository to .m.
Okay.
Then again we have to pull that push that b.jar to the remote repository.
No. See, okay, yeah, you're saying like, a.jar you pulled it here, but you don't push a.jar. You will push the b.jar to remote repository.
Okay, that's what I'm saying. So that another person will have the updated one.
Yes, of course. Yeah, they will be having. See, if somebody wants to b.jar, they can take it from remote repository. It's shared actually.
Okay.
Yeah,
so that we have to do, right? The B person has to be developed.
Yeah, B developer is supposed to push it. See, you see this arrow, right? A is pushing the jar to here. Similarly, B is also supposed to push his jar to here actually to the remote repository.
Later on.
Yes, later on. Once his compilation is done.
Okay, that's what.
Okay, so I'm back. Now, the thing is, you understand the entire architecture. What we are supposed to do it, we have to set up this part is there, right? The remote repository. Okay, so this remote repository we need to set up now. Okay, and how to set up this remote repository within the company, and how do we give the access to the people, and what kind of repositories we can set up in the remote repository. All these things we'll see it now. Okay, fine. So I'm just saving this diagram so that you can